Welcome to the introductory series of training videos for SolidCAM. This video's topic is starting a new milling cam part setup. So if you're starting a new milling part like we see on screen, basically what you're going to do is first open up the part inside your SOLIDWORKS. Because of our integration inside SOLIDWORKS, basically that's all you have to do to start. Just grab your part, whether it be a translated part file or an original SOLIDWORKS part file. As soon as it becomes a SolidWorks part, you can program off of it and get all the associativity and all that stuff related to our toolpath. But let's start by opening it up inside SolidCAM. So we've got our part open. I'm going to go to Tools, SolidCAM, New. You can see here we have 4 modules that you can choose from. We're going to be doing a milling part today, so I'm going to choose milling. If you are doing any kind of turning or mill turn part, then look in the rest of the series of videos for the new turning or mill turn part setup. So let's click on milling. What this will do is bring up essentially our first window from SolidCAM on the left side there, where we're choosing between external and internal. Now, these settings here that we see on the side here are defaulted according to our SolidCAM settings, which was covered in a previous video in this series. So external versus internal. Essentially what you're doing here is you're telling SolidCAM what your relationship with the original SOLIDWORKS part file is going to be. So if we selected internal, what we're actually doing is adding a folder to this SolidWorks part. So it's still the same file that we're working in, the original SolidWorks part file, but we're adding a folder to the feature tree that would have all our tool definitions, operations, definitions, everything to do with the actual programming side of things would be added to a folder that is part of this feature tree. And the purpose of the internal option is really just for file management. If you've got a Vault software or PDM or anything like that where you are checking files in and out of some sort of network location, or maybe you do have just a simple network and you just want to control just one file internally without some sort of third-party program, then internal is essentially for that purpose. It really just allows you to do the design and the program in one file, and you can move that file around wherever you need to. That does mean that anyone who uses SOLIDWORKS can open up that same file, but if they don't have SolidCAM, then they won't be able to look at the programming side of things. And internal is limited in that it is the original SOLIDWORKS file. So in this case, this is a SOLIDWORKS part file, which means that I can't do anything else in here in terms of assembly. I can't add additional solids that represent vices and clamps. I can't add additional solids that represent stock unless it is part of the original model, like this guy is here. So it is limited in whatever you bring in from the front end. Now, the external is not exactly the opposite of that, but it does give you some more functionality. So in that case, it's a little bit opposite. Essentially, what external is, you are creating a separate SolidCAM only file. What this means is we're going to take this SolidWorks file that we have in front of us, make a copy of it, and add it to a SolidWorks assembly that is essentially that SolidCAM file. It has a different extension, so PRT or PRZ, as you see in the brackets there, but it is a type of SolidWorks file. So it is something that you can bring in additional vices and clamps, solids, to better simulate your part. And in that assembly file, the copy of the SolidWorks model will be relabeled as design model. So any talk of design model associativity is to that actual model. So once we open this up, I'll show you exactly what that assembly looks like. But basically, when it comes to associativity, both versions of the file format allow for associativity. In the case of internal, it is direct. You're working off that SolidWorks model, so any changes to that SolidWorks model will update your toolpaths, update your G-code. Whereas with the external, we're still working off of a SolidWorks model. It just happens to be a copy of the original, but that copy remains associative to the original model from SolidWorks. So if on the design side of things, a change was made, hole location, pocket depth, whatever the change was dimensionally, or if a feature was added in terms of 3D toolpaths, your toolpaths will recognize that change, update themselves, and then you can repost the code for a new version of the file. So revision, change, that sort of thing is handled by our associativity. Because of the increased functionality of the external, that's usually what we recommend. So I'm going to show that today in this video. So from external, seeing as it is a separate SolidCAM file, what you're actually going to be doing is giving it a name. Now, by default, the name of the file is the same as the SolidWorks file. So you can see here that it has that name there. In this case, it has a -1 in the case that that file has already been created. So let's say you are adding SolidCAM files to or adding SolidCAM files based off of a single SOLIDWORKS model. You might have a Rev1, Rev2, Rev3, or Machine 1, Machine 2, Machine 3, whatever the differences are. You can have multiple SolidCAM files off of one SolidWorks file. And all it's going to do is, if the name is the same, just add that -1, -2, whatever it is in sequence. For what we're doing here, I'm just going to add in my initials there. And the directory we're saving it in, because this is a separate SolidCAM file, it's going to ask us where we want to save it in the case that we want to save it separately from the original model. So if I uncheck this box, you'll see that it saves it to the default location according to my SolidCAM settings. Again, that was covered in our previous video. So in this user directory, all my SolidCAM files will just be put there, regardless of what file I have open. But if I'd like to browse to a different location, I can click on Browse, and then save that to whatever location I like. If I want to skip the step of having to find where the original SOLIDWORKS model was, I could just check this box here, which is why I had it defaulted, and it saves the SolidCAM file side by side with the SolidWorks file. So that eliminates the need to have to browse to where I found that file. If I want those two files to be side by side, let's say in a job folder or something like that, this gives me the ability to just skip the step and just say, put it wherever I found it from the original SolidWorks model. And then lastly, it defaults to inch units, but the original model, if the original model was in metric, it wouldn't matter. Once you open up a SolidCAM external file, you work in the units that you'd like to work in. So I'm just going to click the green check mark, and what will happen is it'll close this original SolidWorks model, open up a copy of that model inside of this new assembly. So essentially, you'll see that we're not actually leaving SolidWorks, we're just opening up a new file. So this is technically a SolidCAM file. But because the functionality is the same as SolidWorks, it really doesn't look like we left SolidWorks. We're just opening it up inside of SolidCAM, which is inside of SolidWorks. Okay, so before we get into this window here, I'll show you the feature tree. We are now inside of an assembly file, relabeled with the name that I took from the original SolidWorks model. In this case, because I toggled between the address, use model file directory and such, it reverted back to that -1. But if I had already just decided what address I wanted to put it in, it would have kept my -mp. So this being a assembly file, you can see that it has the same name as the original SolidWorks file, but in the assembly we have design model, which is just the relabeled copy of that original SolidWorks model. So this gives me the ability to go in here and make design changes. These design changes will not be seen by the original SolidWorks model. So that associativity I mentioned really only goes from the original model into SolidCAM. Any changes you make to this design model within SolidCAM don't go back and update the original model. So this maintains that functionality of only the designer is allowed to make those changes to the original model. The only changes you would make here would be whatever would make it more machinable, or if you need to add certain geometries to make your toolpath a little easier in the case of 5-axis or something. So you have full functionality here to actually modify the model. It just only exists inside of your copy of that model. So everything under the design model header is associative. So once there's a change on the original SolidWorks model, those changes will be incorporated here, overwriting whatever's in here. So if there's some geometry or a sketch or anything like that you're adding to help with the programming of your part that you'd like to retain, regardless of changes to the original model, then you can put it under CAM. This is a component that's added to this assembly just so you have somewhere to put stuff that is not associative. And that's why in this CAM solid here, there's nothing in here, just the planes and the origin. Let me just minimize that. So on the left side is actually your first window from SolidCAM. This is going to be the definition of the machine, the material, the coordinate systems. This is everything to do with the programming side of things, and this is the main focus of this video here. So the first thing we're going to do is choose our post processor. So the defaulted one here, the one that automatically was selected, was again detailed in our one of our original videos, the global settings video. But let's say I don't want to work on this machine today. I want to work on one of my other machines. All I have to do is go to the pull-down menu and select the machine that I'd like to work on today. So in terms of milling, I'm probably going to work with my Haas SS. So I just need to find that Haas SS post-processor. And you can see that there's many post-processors that either come with the software or that I myself have collected over the years. So essentially all I'm doing here is I'm just going to grab a Haas post-processor. So let's just grab the VF4SS. The post-processor that you select dictates what you're able to do within the SolidCAM file. So in this case, I'm choosing a VF4. I'm going to have feeds and speeds that are appropriate for this, the maximum feeds and speeds that are appropriate for this machine, maximum travels that are appropriate for this machine, and it actually happens to be a 5-axis post indicated by the 5X. So that should open up the 5-axis toolpath. So even though this is the milling module covers 2.5D, 3D, 4-axis, 5-axis, 3+1, 3+2, whatever your machine does in terms of milling, this is the module that you would choose. The post will dictate what you're able to do with the actual module. Next is the coordinate system. So the coordinate system inside SolidCAM is basically the offset on the machine. So on this HOS, we're basically looking to set up G54. Within the software, it's called MAC1 position 1. MAC number is the offset number on the machine. So in the software, it's MAC1, MAC2, MAC3, MAC4. On the machine, in this case, it would be G54, G55, G56, G57. So the offset number is really just the numbered offset on the machine. So the first offset, second offset, and so forth. The position number is an angle or an index off of that coordinate system. So MAC1 position 1 is when everything is set to 0, X, Y, Z, A, B, C. So MAC1 position 2, MAC1 position 3, those would just be indexed angles off of that setup axis. That's more for 5-axis work, 4-axis work. So that will be covered in the training videos you'll find on the other sections of this YouTube channel. In the definition options, there are 5 options here. You can decide which one you use based off of the geometry that you have available to you. More often than not, you're going to use select face, but these other ones here are for when you don't have a nice solid model. For instance, by 3 points associative actually requires you to choose an origin, a point in the X direction, and a point in the Y direction. So for instance, the origin, let's say I want to use this corner here as my origin. Then I want my X-axis to be in this direction. So I'll choose an origin or a point over here, which gives me my X positive axis. And then I need my Y direction. So I'm going to choose a point in the Y positive direction. X and Y gives me Z. So you'll use this option when you only have point data. This could be from a sketch. This could be from a translated DWG or DXF file. This could also be from a solid, but possibly the solid does not have straight edges or flat faces. So the vertices, the endpoints, any kind of point data on screen is useful for the by 3 points associative. If you're using sketch data and you have straight lines, you can use the define option, which works in a very similar way. I can choose an origin. I can choose a line or a point in the X direction. That'll give me my X positive axis. A line or a point in the Y positive direction. X and Y gives me Z. So again, this would be useful if you only have sketch data or you do have a solid that has these straight edges but no flat faces. This again will just give you the ability to define a coordinate system. Normal to current view is more for 5-axis. All it's really allowing me to do is eyeball my part. So let's say I wanted to make sure that I deburred an edge in here, and this point of view of this screen is exactly the point of view I want for the tool. I can click on Capture Current View, and essentially what it does is it makes the Z positive axis come out of the screen, the X positive axis goes to the right of the screen, and the Y positive axis goes to the top of the screen. This, again, would be for those index positions. MAC1 position 2, MAC1 position 3. The reason being is because it defaults to the origin of whatever I've set up as my setup axis. So if I set up those MAC1 position 1s I did a second ago, then that would be my origin for this index position here. So really only for 5-axis work, but it's very helpful if you don't know what angle the part should actually be at to achieve that coordinate system, to achieve that, that operation. Select coordinate system opens up this menu here that's currently blank. That's because it brings in any coordinate systems that were defined within SolidWorks. So if inside SolidWorks you had defined a coordinate system that was center of mass or somehow a location based off an assembly, for whatever reason, if you've defined a coordinate system inside SolidWorks that you'd like to translate to a SolidCAM coordinate system, then you can do so with this option here. And the reason being is because the SolidWorks coordinate system that's on the bottom here no longer gets used once you add your SolidCAM coordinate system. So once you do that, everything's referencing the SolidCAM coordinate system for feeds and speeds, directions, which way is up. All that stuff is related to the SolidCAM coordinate system. But like I mentioned at the beginning, select face is the one that is more often used. And that is because all select face needs you to do is choose a face to orient your z-axis. So for instance, the top of this stock face here would be my top face of my part. So I want z to be perpendicular to that face. If I just click on that, it makes the z-axis, which is always your tool axis in milling, perpendicular to that face. What it'll also do is pop up these lines and these points, this sketch that pops up here. Essentially, that is to help you to locate your origin. With the first click, it actually places the origin in one of these directions here, one of these positions. The top corner of the model box, the bottom corner of the model box, top center, bottom center. The model box being referenced is this box here. This sketch represents the model box. This is not the stock. What this is the outermost edges and tangent faces of whatever solid I selected. In our case, I actually have a solid on screen that represents my stock, so it actually makes it really easy to find the corner of my stock. But if I have just the target model, the final model, so what we'll do is we'll just jump out and then we'll jump back into the model. What I'm going to do here is I'm going to choose the top face or any face of my solid that's facing in this direction. I'm just going to click on select others, and I'm going to choose the face of my target. So what I'm doing here is just choosing any sort of horizontal face that's in the direction of the top of the face, and it places the z equals 0 on the very top face of my part. You can see that it actually found the tangent edges or the outermost edges of that model. Each line represents an edge of the box. So this right here is tangent or in line with that face there, that face there. This line represents the interface of those two faces. And these points exist at the center of each edge and also the center of each face. Again, in the case that I might want to locate my origin somewhere else. So if I didn't put it in the place I want with the first click, I can always go to pick origin and move it to another origin completely. If even then I don't like where that is, I can move it around using one of the options on the bottom here. So if, let's say, I put it on that face, but the z-axis is actually 90 degrees, sorry, the x-axis is 90 degrees to where that should be, I could do a flip around z and get the x to be pointing in that direction. If it's really not even in that corner, it's somewhere else completely, I can use the modify by delta to move it out. So let's say it probably should have been a ½ inch in x and a ½ inch in y. And that moves it out in its coordinate system. So that was in x and that was in y. And again, this is really just to set up the coordinate system that you're going to reference when you do all of your toolpaths. The reason we get you to do the coordinate system first before you even define the stock is because all you need to define a SolidCAM file is the post and the coordinate system. So if you don't have stock defined, you don't necessarily need stock defined for most of our toolpaths. The 2.5D toolpaths, as long as you're not using any kind of recognition functionality, you don't need to do a stock and target definition. Talking about stock and target definition, let's take a look at that next. So we have our coordinate system, we have our post. Like I said, at minimum, that's all we need to get going. We can do all of the basic toolpaths that we need with just macro in position 1 and our coordinate system defined. Now, as soon as you click on it, it brings you to this coordinate system manager screen. I actually can add as many coordinate systems to this file as I like. So for instance, let's say I'm eventually going to have to do a side 2. I can just click on add. I'm going to use a different offset for that, only because I need to tell SolidCAM we're coming from a different direction. So I'm going to make this a Mac 2 position 1. So that'll output as the second offset on my machine. In this case, it'll be G55. I'm going to set this to top corner model box, and I'm just going to literally just click on the face of the stock here to get it to be the top corner. So in one part file, I'm telling it that there are 2 sides to this part that I'm going to machine. That allows me to retain the updated stock from one side to the other. So if I am using any kind of recognition toolpath, it'll see the amount of material that was removed from side 1 and know that that material has been removed when I do any kind of recognition on side 2. So let's define the stock. In terms of stock definition, again, there are multiple options. Under Define By, we'll see that there are 5. And we'll start with the box. The box is the easiest one. Basically, with the box definition, it places a default box, length, width, and height, around whatever model you choose. So in my model, I actually have a stock solid and the original solid. So I'm just going to click on the original solid for now. I'm going to use Select Other, just to grab that face, just to differentiate between the 3D model that I brought in and the stock that I'm actually going to define in this particular window. So when you use the box definition, there are actually 3 modes you can use: relative to model, absolute coordinates, and stock size. Relative to model asks you to choose the solid that you want to put a box around, and then it asks you the incremental amount of material you'd like to put on each face. So in this case, I actually have it set to 0s, meaning that I'm not adding any material to that green square around my part. So this is actually on size on all faces, even in Z. So if you don't know the size of your stock, this is a good option to use, because you can just tell it roughly either have it on size, or if I change these values, let's say in the X direction, I'm going to put 100 thou on all sides. So as soon as you see me plug that number in there, it updates the solid to have material in the X direction on both sides. Let's do it in the Y direction. So there's 100 thou in the Y direction on all sides. And then in Z, I can add material on the bottom as well. So let's say in the negative Z direction, we'll put 250. So essentially, it expands that box around the solid. So it's relative to the solid stock size. If I go to absolute coordinates, you can see now that it's not asking me for the solid. It's actually just going to give me the ability to define the stock size itself, centered around, or at least referencing, that coordinate system. So right now we're looking at a 4x4 cube centered on my Mach 1 position 1. Now the only reason it's centered is because by default in my settings I have it set to that. But if I like, I can actually change that so that it is, let's say, 5 in the X negative direction. So let's say we're going to -5. In the positive X direction, we're not doing any material. So let's put 0. And you can see that it actually shifts it so that it is 0 to 5 inches in that particular coordinate system. So these are actual coordinates I'm plugging in here. So the outermost edge in Y would be, again, let's say 0 in the positive and -10 in the Y. And again, we're starting to shape it. So again, this is not related to the solid. This is just your actual model size. If we go to stock size, this is actually an even easier option to use, because what this is going to allow you to do is basically the combination of the two. Because if I select on my actual final solid, so let's say again I do a Select Other, and I'll grab that face. As soon as I click on the solid, it gives me the minimum box size for that solid. So in this case, I can tell that I will need a 6x8x125 stock size. Now, let's say that is not the stock that I actually have. I have something that's probably more like 10 by, say, 10 by, maybe not 20, by 2. What this will now do is it should center it inside that stock. So if we look at it from the XY plane, it's actually centered in those dimensions there. And in the Z, it does the same. But obviously, I'm not going to want to center a 1 1/4 thick part in a 2-inch part. I'm actually probably looking to do only maybe the first 10 thou on the top and then have the remainder on the bottom. So in the offset from target section, I can actually give it those values. So from the Z positive side of the part, rather than having it centered, I'll say I only want to do, let's say, the first 10 thou. So that shifts the solid so that we have the 10 thou on the top, and then we have just the remainder of it from the bottom of the target. So that is using the box definition. When you choose a solid, it places the box around it based on one of those modes. Cylinder works in a similar way for the turning operations. We'll see that when we review turning and mill turn in the setup for turning. But for all modes of SolidCAM, you have the ability to do extruded boundary. So in this case, if we switch to extruded boundary, what this allows us to do is choose a chain that gets extruded in the Z direction. So what I'll do is I'll choose just the top edge of my target. I will turn on constant Z to go all the way around. And that will give me an extruded solid based off that profile. It extrudes it in the Z direction that I've defined. This is useful for when you have a wire cut part or laser jet or a water jet cut part where you aren't really machining the outside, but you do want to have that general shape in the prismatic direction, in the Z direction. That's helpful if you have some sort of silhouette part. 3D model goes even further. It allows me to choose a solid we have on screen. So for instance, with this part file that I brought in, I actually have a 3D model that represents my stock. So I'll just click on that, and that defines my stock going forward. So this is actually an associative solid. So as soon as I do this 3D model definition, it'll always track that solid. And if I have a different size of stock, I can update that 3D model, which will update my stock definition, which will update any kind of 3D recognition toolpaths that I have. And then finally, we have the STL option here as well. What STL will ask us to do is browse to a STL file of the updated stock. STL being a third-party format, all we're really doing here is outputting a updated stock from another part file to be used here. A good example of that would be if you've done a part on one machine, and now you need to take that updated stock to another machine, and you don't want to lose the information contained in that part file. Rather than trying to program everything in one file, or if you are changing machines and you're changing the post-processor in use, then you can generate an STL file and bring it into this file here for use as a stock definition. I'm just going to jump out of here. And what we'll do is we'll go back in and we'll just define that solid as our stock. So I'll go and change it from box to 3D model. And then just grab that solid there. Click on the green check mark, and now that 3D model will act as my stock definition. In terms of target, target is essentially the model that represents the final piece. After all our toolpaths, what we want the stock to look like. And in this case, it is just the final part. So again, I'm just going to do a select other to select any face of my target, and then click the green check mark, and that defines the target. That is the model that represents the final part. The purpose of the stock and target definition is mainly for simulation. So in the various modes of simulation that come from SolidCAM, you can check the stock against the target for gouges. You can check the stock against the target to see if there's any remaining material. And if you're using a 3D toolpath, which we'll see in later videos in this series, that actually can generate a toolpath based off of the updated stock. So it can eliminate air cuts if you have a unique shape to a stock, or if you're looking to just say use a particular tool to mill out the part, but you're not looking to choose levels or distances or anything like that, the stock recognition toolpaths allow you to just take that stock definition, put it against the target, and determine what material has to be removed. If we click the green check mark, that confirms all those definitions there, and we can begin to add operations. Operations we will cover in the remaining videos in this intro series. Any questions of this, you can always give us a call on the main tech support line at 1-866-975-1115 extension 2, and stay tuned for the rest of the videos in this introductory series. Thanks for watching.